How's it going, guys? Today we're going to be going over another problem called sum of left leaves. This is a problem that's asked by Bloomberg and Facebook right now. So the problem description says, find the sum of all left leaves in a given binary tree. So pretty simple problem description. An example here is this tree, and it says that there are two left leaves in the binary tree with values 9 and 15 respectively, so we return 24. Okay, so if this question isn't clear, all we're really doing is we're adding this value 9 because it's a leaf node, meaning that it has no left child or right child, right? The left child would be here, it's null. The right child would be here, it's null. And same for 15. The left child is null and the right child is null, and they're both left leaves, meaning that we traversed from the right. So we came from the right and now we went left, and so this is a left child of some other subtree in the tree. So we have two things to figure out, right? One, is the node that we're on a leaf, meaning it has no left child or right child? And two, did we come from the right? So did we move left to get to this node that we're on? If those two things are true, we want to increment a count. So whenever we have a problem with the tree, it's generally probably going to be like a recursive solution. A lot of things in trees are done using recursion, so that's a good hint. The other thing too is that it's not crazy the amount of code that you typically have to write with recursive solutions, so that's kind of like another hint. So like if your problem solution is getting really long, probably a good sign that you've kind of like fallen off the path, and maybe you should consider going down a different path. Cool, so let's try and get right into the solution. So what we want to do is we want to traverse this tree. So we're given the root to start, and at every step in our tree, or at every recursive call that we have, we want to basically check those two conditions. So I think the easiest way personally to check this is from checking above. So if we're on 3, we can ask 1, does 3 have a left child? It does. Okay, cool. So it has a left child. Now we have to ask, is its left child a leaf? So we're really asking, is its left child null, and is its right child null? And if that's true, which it is in this case, we're going to add to account, and then we know we don't need to recurse to this subtree because we've already taken care of its value. There's no other nodes in the left subtree, we know that. So all we have to do is take whatever its value is, which is 9 in this case, and add it to our recursive call when we traverse the right subtree. So I propose we write a recursive solution where our base case could be if our root is null, right? So if somehow we've gotten to one of these null children, we just return 0, right? Because it's not going to add any value. There's no node there. Otherwise, if the thing is a left child, if our current node, so 3 in this case again, has a left child and it's a leaf node, add its value, which we just said we would, and then recursively traverse that node's right subtree, so we would then go to 20 and ask the same kind of thing. Or if the node we're on doesn't have a left child that is a leaf that we have to take care of, we can simply recursively move through both subtrees. So we would just return the result of our left recursive call and the result of our right recursive call. So hopefully that made sense. If it didn't, we're going to jump into the code and we can kind of go over it then. So we said our base case, and typically a lot of times your base case in a recursive solution with a tree will be if your root's null. So if our root is null, we have no value to add, right? So if we have no value to add, we're just going to return 0, so we don't actually affect our sum of the left leaves. Otherwise, we said if our current node has a left child, so let's check that. So else if root.left is not equal to null. And now the second thing that we said we want to check is if it's a leaf node. So how do we do that? We check if its left child and its right child are both null. So if root.left is not null, and root.left.left equals null, and root.left.right is equal to null, then we know that the thing to the left of us currently is a left leaf node. So we should add it to our sum. So we'll say root.left.val. And now the only thing left to do, right, so this is the case, we're right here. So we added 9, and now we need to actually still account for this subtree, the right side. So we're going to add the root.left.val plus sum of left leaves, and now we're just going to recurse on the right subtree. So we'll say root.right. And otherwise, if neither of these things are true, meaning the current node we're on is not null, and the thing to the left of us is not a leaf node, a left leaf node, all we have to do is recursively traverse both subtrees. So we can simply return, oh, we should have a return statement here as well, sorry. We want to return the result of whatever those two subtrees give us back. So we'll say return sum of left leaves root dot left plus sum of left leaves root dot right. Let's make sure this works. Oh, 14, no. Whoops, forgot an L, sorry. Awesome, and it's accepted. So that's how to solve sum of left leaves. If this was helpful, guys, be sure to let me know. Leave a thumbs up and subscribe. I release a video every single day so you guys can try a new tech interview every day. Yeah, if you guys need any help on your interviews or anything, feel free to reach out to me. A couple people have, and I really appreciate it. I'm happy to help you guys however I can. Good luck on your interviews, and I'll see you guys next time.